Okay, good morning, everybody. So, I assume that most of you are Python developers. So, let's think together, why do Pythons live on a land? The answer is here. It's because we are above the sea level. This is our company, and this is me. So, who am I? I'm Layla. I'm a computer engineer. When I was 17 years old, I invented a car device to limit from car accidents. And I won the second place and traveled to NASA. And now currently working as a data analyst in an amazing company called Antidote Health. I believe that intellectual growth commences at birth and only ceases at death. So because of that, I'm a self-learner and I love learning so much. And I'm passionate in machine learning. And I hope that next year I will participate again in PyCon using AI with an amazing project. So what about the amazing company? Antidote Health, it's a digital AI-based health organization, operates 24-hour to provide quality, affordable healthcare to all Americans. It's basically like بتوخ لأمي, but in America, because you know that the healthcare in US is very bad. So we provided doctors that can treat our patients, diagnose them, give them medication, prescriptions, and a lot more of services. So let's start by playing a game. Would you rather? Would you rather give up air conditioning for 3 days for about 40 Celsius or do an employee roster? So I bet that most of you, of course, will choose the employee roster, but anyone who's in charge and doing the scheduling for employee, he will have a pressure, high temperature, and maybe some mental health problems. But don't worry, we are at Antidote Health. We have great doctors that can treat you. So what are we busy about? We're busy about of solving and finding an optimal solution for optimization problems, like assignment. So assume that we have multiple workers that need to assign to a task, and no two workers can have the same task. At the same time, we need the minimum cost. Another example is routing. Like the TSP routing problem, it's a famous problem that traveling salesperson to find the shortest route for a salesperson who needs to visit a lot of customers at different locations and return back to the same point. Also, we have the delivery and pickup routing problem and a lot of scenarios of vehicle problem. Also, we have the scheduling for machines and for employees. Scheduling for machines, assume that we have multiple jobs and each job is separated to multiple tasks. Each task is implemented using a machine. And to get the job to be completely done, we need to assign each task to a machine with considering the minimum time. And also we have the scheduling employee, which is a problem that we faced in Antidote Health. And it's a really very, very big problem that anyone who's in charge in doing an employee scheduler will not be able to find a balanced and fair scheduler for their workers. And the process itself, it's a time wasting, and there will be a lot of turnover error due to the manual work. Also, as a human being, we need to consider a lot of variables like the available time for the doctors, if they want to work AM, PM shift, their vacations, day offs, and a lot more of variables. Also, we need to consider a lot of constraints, like if a doctor needs to be assigned to at minimum 2 nurses or 8 hours per day, and a lot more of constraints that we are dealing with in the health domain. So what is the moral of the story? The moral of the story is to build an automatic scheduling and to stop exhausted manual work. First of all, we need to define our problem. Is it a machine learning problem? It's a linear programming problem? Is it a dynamic? So we figure out, after a lot of thoughts, it's a linear programming. So we need to solve our problem before we start typing, which means coding. And basically, each optimization problem, it's a linear programming. First, each linear programming has to have objective function, which is basically the quantity you want to optimize, a math function or equation to maximize or minimize. Second, the variables that you have, like the availability time, their vacation, day offs, how many hours they want to work per day, and a lot more of variables. And constraints. Constraints are the restrictions that we need to apply on the set of possible of solution that we have based on our variables. Like if the doctor wants to work AM, PM, no, it's a variable. Okay, if we need to assign, for example, 2 shifts maximum for each doctor, or how many nurses do we want to assign for them, like it's according to the labor restriction. And of course, the output, how we want to define our output. Is it data frame? Is it the charts? So how we do it in Antidote, we follow a process, which is first we get our data from the doctors, their availability time, when they want to work, and a lot more of variables. Then we have variables about our doctor, if they are full-timers, part-timers, where they can serve their services, in which states, because in America, if you should have a license in each state if you want to work in all states. Like according to your license, you can serve your service. And then we pre-process the data and then run a model. And finally, we have the output of the model, which is the scheduler. Our customer support, who's responsible to do this employee roster, review the scheduler if they want to update anything. And then we have the final scheduling and we update it to our data warehouse. So what is the amazing tool that we used? It's a really fantastic tool that can solve very big problems that we are currently having in the real life, like the routing, the assignment, the scheduling for machines, for employee. So it is the OR tools. Does anybody heard about it? Okay, nobody. That's cool. OR tools. It's an open source software for combinatorial optimization, trying to seek the best solution out of a very large set of possible solutions, along with a high level of API. After we define our problem, we know our variables, our constraints, our linear objective function. Now it's time to start coding. First of all, we need to choose appropriate solver for our problem. We have linear programming problems and mixed integer problems. There is a solver called MP Solver Wrapper. We use it with underlying solver like the GLOP Google in-house linear programming solver, which is the primary solver for OR tools. And it is used basically for linear problems. And if we have a mixed integer problem like the assignment problem, we use the default OR tools solver, which is the SCIP, and we pass it as an argument to the wrapper. There is another solver, which is for constraint programming, the CP solver. It's basically identifying feasible solution out of very large set of solutions, and it's used also with the routing solver. If you have a routing problem, then you can choose the routing solver, which is basically an extension applied on the top of the CP solver with the CP solver, of course. And the last solver which we basically use is the CP-SAT solver. It's a next generation of the CP model solver, with a closed learning, which is an algorithm to solve the Boolean satisfiability problems.
Could you give an example of a problem that you were able to solve with this?
It's the scheduling problem.
But in more mathematical terms, how this problem looks like?
In mathematical way, I didn't put an equation for it, but for example, you have, let's take a small example, okay? You have two doctors, and you have available time you take the data from them, like the variable time, the day off, vacations, and a lot more of variables. First, you have your variables, okay? And then you want to put your constraints. Each doctor can work 2 hours per day. Great. And their availability time, they have 8-hour available time, but they just need to work 2 hours. Great. And your constraints that no doctor can work more than 1 hour. Okay. So your objective function is first you put your constraints. You have the area of visible solution where you draw your constraints. So there is a possible solution there, right? So then you need to, for example, minimize or maximize if you want to if you want to put them to assign the doctors that have the most licenses in America. So here you want to maximize the variable of the licenses.
The licenses?
Yeah, like where they can serve.
Okay. Yeah.
Okay.
Let's finish and then.
Okay, great. Okay, so if the CP-SAT model, if the model has no objective, then it will search for the first solution and return it back to you. And if the model has an objective, then it was an optimal solution, then it will return the optimal solution. And how is it implemented? Using two classes. First, the CP model class, which is basically provide us the methods to create the variables and the constraints, and the CP solver class, which is encapsulate the solve API and offer helpers to access the solution that found by the solver. And second, we need to start creating our variables. So for each doctor, we made a dictionary, putting all the information that we take it from him, and also joining our information about each doctor, for example, where they can serve, if they are full-timers, part-timers, and a lot more of variables, put them in one dictionary for each doctor. And then we start declaring the constraints. We have linear constraints, or tools basically deals with a lot types of constraints, like the linear constraints, the Boolean constraints, or implications. Also the no overlap constraints or cumulative constraints. It's basically that the task can overlap, but without overloading the capacity. And if you have a routing problem, which is, you can use the circuit constraints, which is enforce your variables to make a closed loop. After adding the constraint, here we need to define our objective function. It is the quantity that we want to optimize or minimize, which is basically a math function. And then we need to start to check the status. So if we want to see the status, if the model want to return us a optimal solution, we check it by the optimal status, or visible. Visible means that there was a solution was found. It will return us the first solution, but of course we can print all the solutions. And the invisible status, it basically means that the solver doesn't have a solution according to the current variables and constraints. And finally, we present the output as a data frame and Gantt chart, but of course you can present it as what chart or data frame you like. So you win. Anybody who, when start the presentation with would you rather, and if you choose to do an employee roster, then now all of us will choose to do an employee roster, because now it's a process of automating the scheduling. So what we're going to benefit from automating scheduling, first, we're going to have consistent result. It's more efficient. It will maximize employee productivity and satisfaction by meeting their needs. And it's time to start using the power of automation. So if you think now, if you have any problem that you are facing right now and you're doing it manually, think of how to do it automatically. And I'll be happy if you connect me via LinkedIn, and you can reach me out via email. And don't forget to follow up on LinkedIn and Antidote Health. And thank you. So before I'm going to receive any questions, I want to say something very important to me. Before 3 months, we had a workshop in our company, and there was a section there. It's called acknowledgement. So I first want to acknowledge my brother who take a vacation from his work and come to support me. So thank you. And also I want to acknowledge all the organizer for this amazing conference, to unite all the Python developers. So and especially Simzak, because he's the only person that I know it from yesterday. And he's just an amazing organizer, but it's the thankful is for everybody who is responsible for this event. And last but not least, I want to acknowledge my manager. She's the superwoman, the vice president of our research. She's just an amazing manager, human being that created on the earth. She was supporting me all over my way, and she just like to see her employers are raising up in their careers, are improving, developing. So thank you for Mila. And of course, I want to thank each one of you for not getting bored of this 20 minutes presentation, and for your valuable time to make this occasion memorable. So thank you all. Now I can receive any questions. Yeah.
Can you go over more the variables that you've taken and how much do employers and doctors preferences go into it, and what you mean by that? What operations are allowed to do?
Yeah, sure. Okay, so we have an Antidote Health over 100 doctor, okay? And each doctor, what I mean by license is that when a doctor wants to serve in the US, in the healthcare, he should get like the license that he can work in this state. For example, if you are from New York, you cannot work as a doctor in Florida. You need to get a license to work in Florida. Okay? So this is what I mean by licenses. So I took all their variables, like when they want to work, their available time, how many hours they want to work per day or per week or per month. Okay? And I make a dictionary of all of these variables. If they want to, also there are a lot of variables, like if they want to vacation in specific days, or if they want to work AM, PM shifts, it's like according to them. Great. And then what is the constraints of our labor? The restriction that we have. For example, we cannot assign more than 8 hours shift for a doctor, even if he were requested more. And we have a lot more of constraints. And our objective function is, first, we need to assign the doctors that have a minimum available time. So we prioritize them. And also, we prioritize all the full-timers. So if a doctor is a full-timer, we prioritize him. Then he will get all the requested hour that he asked for. And this is the objective function that we have. We actually minimize or
Minimize unused time.
minimize what?
Unused time.
And also you maximize coverage. You basically want to have a 24/7 service and as maximum stations you can. You want to provide service all over the state. That is the target.
Yeah. So, thanks, everybody.